Now read along as the directions for Part C are being read. Part C. Directions. In this part of the test you will hear 7 short talks. After each talk you will hear some questions. The talks and the questions will not be repeated. After you hear a question, read the 4 possible answers in your test book and choose the best answer. Then, on your answer sheet, find the number of the question and fill in the space that corresponds to the letter of the answer you have chosen. Here is an example. On the record you hear, "Listen to an instructor talk to his class about a television program."
I'd like to tell you about an interesting TV program that'll be shown this coming Thursday. It'll be on from 9 to 10 p.m. on Channel 4. It's part of a series called Mysteries of Human Biology. The subject of the program is the human brain, how it functions and how it can malfunction. Topics that will be covered are dreams, memory, and depression. These topics are illustrated with outstanding computer animation that makes the explanations easy to follow. Make an effort to see this show. Since we've been studying the nervous system in class, I know you'll find it very helpful.
Now, listen to a sample question. What is the main purpose of the program? In your test book, you read A. To demonstrate the latest use of computer graphics. B. To discuss the possibility of an economic depression. C. To explain the workings of the brain. D. To dramatize a famous mystery story. The best answer to the question, "What is the main purpose of the program?" is C. To explain the workings of the brain. Therefore, the correct choice is C. Now listen to another sample question. Why does the speaker recommend watching the program? In your test book, you read A. Is required of all science majors. B. It will never be shown again. C. It can help viewers improve their memory skills. D. It will help with coursework. The best answer to the question, why does the speaker recommend watching the program, is D. It will help with coursework. Therefore, the correct choice is D. Now we will begin Part C with the first talk.
Questions 38 through 41. Listen to part of a lecture in a developmental psychology class.
Developmental psychologists study people as they age and develop. So the obvious research approach would be to study a group of participants over several years, right? This is called a longitudinal study, where we observe the same participants repeatedly over time. For example, suppose you want to study shyness in children. To see, say, if children who are shy at age 3 become less shy as they grow. Well, you'd start with some 3-year-olds and observe them at various times over several years. Now, here we're faced with some practical issues. Such research takes years to complete. Will researchers be available that long? What about the participants? Will they be available the whole time? How big a group do you need to start with to ensure there will be enough participants at the end of the study? There are 2 other research approaches, the cross-sectional study and the cohort study. The cross-sectional study observes children of different ages at a single point in time. So back to our study of shyness in children. A cross-sectional approach would ask a different question, something like, is the average 3-year-old shyer than the average 6-year-old? This is research you could conduct in a limited period of time. But remember, the approach you use, longitudinal or cross-sectional, affects the focus and the design of your study. This is also true of the third approach, the cohort approach. Children born in the same year are called cohorts. Let's see how this approach would work in our shyness study.
Number 38. What does the professor mainly discuss? Number 39. What question is investigated by the research studies that the professor describes? Number 30. What is one of the problems with longitudinal studies that the professor mentions? Number 41. How would a cross-sectional study observe children? Questions 42 through 46. Listen to part of a lecture in a geoscience class.
Gravity is not constant on Earth. One way it varies is with Earth's mass in a particular location. For example, an area with greater mass, like a mountain range, well, gravity will be stronger there. These anomalies, these differences in gravity from place to place, are measured by highly accurate instruments on a pair of satellites. These instruments generate what are called gravity anomaly maps. Gravity anomaly maps show, as I said, that gravity is strongest over mountain ranges, and it's weaker over places like depressions in the Earth's surface or over water-filled areas like oceans or aquifers. Aquifers are underground formations that hold water and are often the main source of water for people across large geographical areas. Gravity over most types of rock is pretty stable, but it fluctuates over water because water volumes vary as a result of evaporation, precipitation, and human activity. For instance, gravity anomaly maps show that aquifers supplying California's agricultural region are shrinking. Underground water is being used for irrigation and human consumption faster than it can be replenished by rain or melting snow. By precisely measuring tiny gravitational changes over an aquifer on a monthly basis, the satellites tell us when an aquifer is at risk of going dry. Then, water conservation efforts can be put in place to reduce the amount of water being taken out of the aquifer. Similarly, gravity anomaly maps can reveal information about Earth's changing climate. For example, changes in sea level can be seen in minute gravitational fluctuations.
Number 42. What does the professor mainly discuss? Number 3. What does the professor emphasize about the instruments on the satellites he mentions? Number 44. According to the professor, where is Earth's gravitational force the strongest? Number 45. What do gravity anomaly maps indicate about California's agricultural region? Number 46. What does the professor say about climate change? Questions 47 through 50. Listen to part of a talk in a United States history class.
While we're on the topic of things that technology has made obsolete, I'd like to spend a few minutes on the ice industry, one of the major industries in the United States in the 1800s. Now, before refrigerators came into common use, people in rural areas often had a well or a spring house to keep perishable foods fresh. We're all too young to have used one, but a spring house was a small building that people would build over a spring. Farm families back then would rely on cold water from the spring to help keep dairy products or meat cool. But people in cities would have ice boxes instead. And they'd buy blocks of ice to put in these ice boxes. And then they'd pack all their milk or meat inside to keep it fresh. So, until refrigerators made it obsolete, the ice industry supplied city dwellers with these blocks of ice. Now, by 1800, people had learned how to harvest blocks of ice from lakes and ponds, and later to cover this ice with hay and store it in ice houses. These ice houses were enormous, among the largest structures anywhere in the country at that time. Ice houses were so important that they often had railroad tracks going right up next to them. In addition to being transported by train, ice was delivered by ship, all along the East Coast, or further inland by canal boat. Eventually, the industry supplied blocks of ice to almost any place in the country where people could afford such a luxury.
Number 47. What is the talk mainly about? Number 48. What does the speaker imply about spring houses? Number 49. According to the speaker, what made the ice industry obsolete? Number 50. What was the purpose of an icebox?
This is the end of Section 1, Listening Comprehension. Stop work on Section 1. End of recording.